A loop is like a merry-go-round that keeps going round and round until we tell it to stop. In Bash, there are three main kinds. One for works like a teacher handing out a list of names one by one. Example. For file in star.txt, do echo processing $file done. The loop runs once for every star.txt file. 2. While similar to a while loop in school math, while the answer is not right, keep trying. It checks a condition before each step. Counter equals 1 while counter less than or equal to 5, do echo step $counter, counter plus plus, done. The loop stops when the condition becomes false. 3. Until the opposite of while it runs, until a condition becomes true. N equals 0 until n greater than or equal to 3, do echo n is $n, n plus plus, done. It stops when n reaches 3. All three loops let us repeat actions without writing the same line many times. Sometimes we need to leave a loop early or skip a step, just like a child might stop playing a game or skip a turn. Break ends the whole loop right away. For I in braces 1 to 10, do if I equals 6, then break end if echo I done. Continue skips the rest of the current iteration and jumps to the next one. For I in braces 1 to 5, do if I modulo 2 equals 0, then continue end if echo odd I done. Exit status handling every command returns a number 0 equals success, non-zero equals error. Inside a loop we can test it with $? Or with &&//. While true, do copy source.txt destination.txt, and in break end do echo copy failed returning sleep 1 done. Explanation: when a loop needs numbers or calculations, Bash gives us a few tools. Arithmetic expansion, like a calculator you can put inside a string. For I in 1 to 5, do square equals I times I echo I squared is square, done. Expr, an older external program, useful when you need portable syntax. Sum equals expr 3 plus 4. BC, a powerful calculator for floating point math. For I in sec 0 0.52, do result equals echo scale equals 2 semicolon sqrt I pipe bc minus l echo sqrt I equals result, done. Using these inside loops lets us do everything from counting items to solving equations. A function is a mini script that we can call whenever we need it, just like a reusable Lego block. Defining: start with the word function optional and give a name. Define a function named myGreet that echoes hello, $1 exclamation mark. The comment says $1 is the first argument. Invoking: write the name followed by arguments. Call myGreet with the argument Alice. Scope: variables created inside a function are local by default only if we mark them with local. Otherwise, they affect the whole script. Set counter equal to 0. Define a function increment that creates a local variable counter set to the first argument, increments counter and echoes the counter. Call increment with 5, it prints 6 while the outer counter remains 0. Return conventions: a function can return a numeric status from 0 to 255 or output text with echo. The numeric status indicates success or failure, while text provides the actual result. Define a function add that echoes the sum of its first and second arguments and returns 0 to indicate success. Assign result to the output of add called with 3 and 4, which yields 7. Functions become powerful when they can understand different kinds of inputs, similar to how a Swiss Army knife has many tools. Positional parameters $1, $2, ... are the arguments. Shift moves all arguments left, discarding $1, useful for processing an unknown number of parameters. Process _args function. Inside, while number sign hash greater than 0, do echo got space $1. Shift now $1 becomes the next argument, end while end function. Process _args abc prints abc. Getops, a built-in parser for option flags -a -b value. It works like a checklist. Parse function. Inside, while getops :a b opt do case opt-in. A echo option -a triggered, B echo option -b with value $opt arg, question mark echo invalid option $opt arg, end case, done, end function. Parse -a -b hello shows both options. Using these tools makes the function flexible and user-friendly. When a script grows big, we split it into small clear functions and let loops call them. Think of a kitchen assembly line. Each worker function does one job, and the conveyor belt loop moves items through. Example: a script that backs up many directories and compresses each. Backup_dir function open brace. src equals $1. dest equals $2 / base name of src.tar.gz. tar czf dest c dir name src base name src. Echo backed up src to dest. Close brace. For d and /home / documents do. Backup_dir d /mnt /backup. Done. The loop decides which directory to handle. The function knows how to back it up. This separation makes the code easier to read, test, and reuse. Debugging is like turning on a flashlight in a dark room to see where you trip. Set -x prints every command before it runs. Set -x for I in brace 1.3. Do echo $I done. Set +x turn off tracing. Trap catches signals or errors and runs a handler. Trap !echo oops. An error occurred on line $lineno !" False triggers trap. Error handling in loops or functions use double pipe or double ampersand to decide what to do when a command fails. Define function copy_file open brace close brace. Inside, copy $1 to $2 or open brace echo copy failed for $1, return 1 close brace. Then echo copied $1, close function. For f in star.txt, do copy file $f to /tmp/ or break stop loop if any copy fails. Done. These techniques help locate the exact line that misbehaves and allow graceful recovery. Speed matters when the script processes thousands of items. Two common tricks are: avoid subshells. Every $open parenthesis 3 dots close parenthesis or pipe creates a new shell which costs time. Use built-ins or loop constructs instead. Slow create subshell each iteration. For f in $open parenthesis ls*.log close parenthesis, do echo $f done. Fast no subshell. For f in star.log, do echo f done. Loop unrolling, do a few operations per iteration to reduce loop overhead, similar to taking bigger steps while walking. Normal loop. For I in brace 1,000 brace, do echo I done. Unrolled process 2 numbers each pass. For double parenthesis I equals 1, I less than or equal to 1,000, I plus equals 2 close parenthesis. Do echo I, then open double parenthesis I plus 1 less than or equal to 1,000 close parenthesis, and an echo open double parenthesis I plus 1 close parenthesis. End loop. Explanation. Putting everything together, here are 3 practical scenarios a junior system administrator might face. 1. Log processing. Extract error lines from many log files and count them. Define function count errors open brace. Local variable file equals $1. Run grep-c error file variable close brace. Set total equals 0. For each log in /var/logstar.log do. Set cnt equal to the result of count errors called with log variable. Echo log :cnt errors. Add cnt to total close done. Echo overall errors total . 2. Batch file operations. Rename a group of pictures by adding a date prefix. Define function rename picture open brace. Local variable date equals the result of date command -r file variable plus %ymd move file variable to target name date _ the result of base name called with file variable. Close brace. For each pic in star.jpg, do rename picture called with pic variable. Done. 3. Mathematical simulation. Compute the first 10 terms of the Fibonacci sequence. Define function fib open brace. Set a equals 0, b equal 1. For I starting at 1, I less than or equal to 10, increment I do. Echo a variable, set next equal to a plus b, set a equal to b, set b equal to next. Close done, close brace, call fib. These examples show how loops, functions, arithmetic, and good practices combine to solve real problems in a clear, kid-friendly way.